Hey, seventh grade, Mr. Olejnik here. Today we're going to be taking a look at equations with variables on both sides, and this is going to be from Big Ideas 1.3. Let's go ahead and get started here. As we start, one thing I want you to remember that whatever we do to one side of the equation, you have to do to the other. We have to balance that equation on both sides. And I know your seventh grade math teachers have been sharing a lot of vocabulary with you in these videos the last few weeks. And so this is just a reminder here. Got our sides of the equation. Now, I prefer that to be the left side, but you can solve it on either side. And then try to get all of the constants or those loose numbers off to the opposite side. So at the end of the lesson, we want you to be able to do something like this. A plus 7 equals 31 minus 5a. So we want to shift all the variables to one side and all of the constant, those loose numbers, to the other. We're going to start by adding 5a to both sides. When we take a look, a plus 7 plus 5a right here, we can rewrite that. That's the commutative property of addition. And now we're going to start combining like terms. The a and the 5a are going to combine. And then over here, we have a negative 5a plus a 5a. Those are going to, what we say, cancel out, or that's the additive inverse property. When added together, it's going to equal 0. And those two will disappear. That's going to leave us with 6a plus 7 equals 31. Now at this point, we have a two-step equation. Mr. Hess just did a great video about this that you watched at your at-home day. Our next step here, when solving is two steps, subtract 7 from both sides. And then we're going to get 6a equals 24. Divide both sides by 6. And voila, a equals 4. So this is what we expect you to be able to do at the end of our lesson. Finally, we want you to be able to be 100% accurate. Okay, once you get that accuracy, then you can work on speed. But let's be sure you're 100% accurate. You can do that by checking your answer. So for this, plug in your 4. 4 plus 7, that's 11 on the left side. 31 minus 5a, well, 5 times 4 is 20. 31 minus 20, that's 11 also. So 11 equals 11. Yes, it checks. Here's one of the examples from the Big Ideas 1.3. We have 15 minus 2x equals negative 7x. And in this equation, we're getting rid of that minus 2x by adding 2x to both sides, keeping everything balanced. We're going to get 15 equals negative 5x. The opposite of multiplying by a negative 5 is going to be to divide by a negative 5, and that's going to give us x equals negative 3. Here's once again an example of a check here by plugging in that negative 3 to make sure everything balances and that our math was accurate. Here's another example using the distributive property. Here we're going to do negative 2 times x for a negative 2x. A negative 2 times a negative 5. Remember, that's going to give us a positive 10. Negative times negative is going to give us yield a positive. On the other side, 6 times 2 is 12. 6 times negative 1/2 is going to give us a negative 3x. Now, once we have this form, we're going to start transferring over our variables to one side and our other constants to the other. We're going to add 3x to both sides here. We're going to get x. All right, welcome back. Let's see how you did. For the first one, we're going to attack that problem by subtracting 2x from both sides. And then we're going to get negative 5x equals 19. The opposite of multiplying by that negative 5 is going to be to divide both sides by negative 5. We're going to end up with the fraction negative 19/5, or we could change it to our mixed number negative 3 4/5, or even write it as a decimal, negative 3 8/10, negative 3.8. All right, how about the second one? Well, let's see. First, we went and subtracted negative 4.5y from both sides. We got their equation negative 2y plus 6 equals negative 1. Now we're going to get rid of that positive 6 by subtracting 6 from both sides. We're going to get negative 2y equals negative 7. Our final answer, 7 halves, or 3.5, 3 and 5 tenths. And the last one, a little distributive property here. We're going to get 24 minus 6z equals 2z. We have to get rid of this minus 6z by adding 6z to both sides. That's going to change our equation to 24 equals 8z. Now we divide both sides by 8, and z equals 3.
Danger, Will Robinson. Danger. No, Will Robinson. Danger.
Ah, the classic lost in space with the robot. Why is this dangerous? Well, because these next ones can be a little tricky sometimes for 7th graders. All right, in this particular problem, when we go ahead and simplify our equation, take a look. Well, okay, we have a negative 4x, so we're going to add 4x to both sides, but watch what happens. It's going to disappear from both sides, leaving us with 3 equals negative 7. Now think about that. That does not make any sense at all. So the equation 3 equals minus 7 can never be true. So when you get numbers or constants on either side of your equal sign that are not the same, either you made a big mistake or you did solve it correctly, but this equation has no real solution. Here's another tricky one. In this case here, after we do the distributive property and simplify, we end up getting 6x plus 4 equals 6x plus 4. The exact same thing. We can continue to simplify that by subtracting 6x. Really, at this point here where it says 6x plus 4 equals 6x plus 4, I already know what the final answer is going to be. But we'll continue to keep simplifying it, and we end up with 4 equals 4. So when we have that final answer, when both numbers are the same on either side of our equal sign, both expressions are the same, that is a hint that this particular equation has infinitely many solutions. So when the number is the same, that equation has infinitely many solutions. That also is true if it says 0 equals 0. The answer is infinitely many solutions. All right, go ahead and write these two problems down in your math journal and pause the video if you're at home. All right, welcome back. Let's see how you did. 2x plus 1 equals 2x minus 1. So we're going to subtract 2x from both sides. We're going to get 1 equals negative 1. That doesn't make any sense. So those numbers don't match. No real solution. How about number 5? After we perform the distributive property here, we get 3t minus 2 equals 3t minus 2. We further simplify it. Negative 2 equals negative 2. That is a match. That means we have infinitely many solutions. Let's try 2 more. Go ahead and write these 2 problems down in your math notebook. If you're at home, pause the video. All right, welcome back. I hope you've been showing your work. Let's see what you have written down. Well, after we perform the distributive property on both of these, we're going to get 2/3 b plus 3 equals 2/3 b plus 18/6. Then I just reduced that to 3. So it's really the same on either side of the equation. We end up with 3 equals 3. And what does that mean when the numbers are the same? That's right. We have infinitely many solutions. Number 7. Once again, perform distributive property on both sides. Balance that out. We get 30 equals negative 4. No Buzz Lightyear here. No real solution. No real solution for number 7. All right, I added this one. I found this from the Big Ideas, and it reads, a polygon is regular if each of the sides is the same length. In math, we say that they are congruent. Find the perimeter of this regular polygon. So we know it's a perfect polygon here. It's symmetrical. Each side is the same length or congruent. So I can set up an equation where 3x 3 times x minus 1 equals 5x minus 6 because those lengths are going to be the same. So there's my equation. And now I'm going to go ahead and proceed to solve this. So I start doing my work, distributed property, balancing it out. I'm going to subtract 5x from both sides. Okay, then I'm going to add 3 to both sides. I get negative 2x, divide both sides by a negative 2. Then my final answer, well, x is going to be 3 halves or 1.5. Now, I didn't find the length. I just solved for x. So now we want to find the length of one side. So what do? That's right. Plug it into one of those equations. It doesn't matter which one. Right? You could do them both and really check and make sure they're correct. I'm going to choose, let's see, 5x minus 6. I'm going to go ahead and plug in 1.5. So 5 times 1.5 minus 6. Well, that's 7.5 minus 6. So, wow, oh, the length is actually the same number as our value for x. That was a random fluke right there. So now we have to find the perimeter of the regular polygon. Well, this pentagon has 5 sides, penta meaning 5. And so 5 times 1.5 is going to give us our perimeter. And I get a number answer of 7.5. There really weren't any units listed here, but they're asking for a perimeter, so I just put the generic word units in there for this one. All right, ladies and gentlemen, I hope you are a lot stronger now at balancing equations with variables on both sides. And please continue in the module and go ahead and begin Big Ideas 1.3. Thanks, 7th grade. Have a great day.